Hello everyone and welcome to Block 2. In this block we're going to be discussing analysis products. And our next product is the ceiling and visibility analysis. And here are the topics that we're going to discuss going through ceiling and visibility analysis. We'll start out with the overview. So the ceiling and visibility analysis is real time. This is updated every 5 minutes, so that can be considered real time. And it's an analysis of ceiling and visibility conditions and also estimates of those. And this is used mostly by VFR pilots, people who are flying with either aircraft that are limited in their capability or pilots that don't have instrument ratings. So it's for general aviation pilots typically, and it gives you the ceiling and visibility in a region or over extended areas. And if you plan to use this, you should probably augment it with more information. You're able to pull up METARs from this, but TAFs and AirMets also are useful. Remember, this is an observation and it's an analysis, but it is not a forecast. So as I mentioned, this is updated every 5 minutes. So that means that if there are special observations, they will be put in as they occur for the most part. And the way they construct this is they have a grid that they plot over the United States, and every 5 kilometers there is a grid point. And at that grid point, they calculate the ceiling and visibility based on observations that are made at the surface, in other words, by ASOS and AWOS machines. So you may not have a grid point right on top of an ASOS machine. It may be maybe 3 or 4 kilometers away, or maybe even farther. So at that grid point, they will estimate the ceiling and estimate the visibility based on the nearest ASOS observation. So across the United States, there's over 2,000 observation points, meaning ASOS or AWOS machines, and that information helps populate this grid. There are 2 different views that are available, either the CONUS, Continental United States, or regional views. The regional views are shown at the bottom on a map with cities in those regions. So what you get with either one basically is, of course, METARs that are plotted, and also the METARs have ceiling and visibility. And then also you'll get an analysis of the weather conditions or ceiling or visibility depending upon what you select. Now the stations that you see on this map are not all the stations that are being used to analyze the weather, whether it be ceiling, visibility, or flight category. It's usually just a subset. And depending upon the view that you're in, you can zoom in and see more and more stations because it auto-populates the number of stations based on your zoom level. So if you want more detail, you got to zoom in and take a look in the CONUS view. This is not available in the regional view, but in the CONUS view. And as you increase the zoom, of course, you'll see more stations because they autofill the station density. In other words, the station density increases as you zoom in. And with CONUS view, you can click on a station and you can get the METAR. Or if you have under plot options, if you have hover selected, then as you move your mouse over the stations, you will see the METAR for that particular station. Now in the regional view, you don't have that option. There's no zoom, there's no METAR mouse over or click on. In other words, what you see is what you get. You got a static picture for the most part. So it gives you ceiling, visibility, weather conditions, and flight category for selected stations. And that's not all the stations. Remember, they can't plot all the stations on here. It'll look like just a mess. So they try and use selected stations to give you representative weather conditions in that area. But when they analyze the conditions, in other words, when they use that grid, they will plot everything. In other words, they will plot the analysis using that 5-kilometer grid. So what we're going to look at is ceiling visibility and flight category for the CONUS view and also for the regional view. So you get to select what kind of analysis you want by pulling down underneath the data options. They have a menu there where you can select either the ceiling height, the surface visibility, or the flight category. So let's first look at how they analyze ceiling. What they do is they plot a grid, of course, across the United States. It's a 5-kilometer grid. We've talked about this already. But then using METAR data, in other words, ASOS and AWOS stations that are close to these grid points, they estimate what the ceiling would be at that grid point. So if a grid point is between two METAR stations, one station has a higher ceiling, another one has a lower one, that 5-kilometer grid point in between those two will be kind of an average between the two. They use some sort of weighting scheme. It's not necessarily an average. Also, another thing they do is if the terrain varies, then they will compensate the ceiling based upon the rising or descending terrain. So in other words, there may be a station in a local area where the ceiling is 1,000 feet. And if the elevation goes up to the east, then it assumes that the ceiling is coming down as the terrain goes up based on the local METAR. And then another thing they do is they use ghost satellite imagery to determine where there's clouds and where it's clear, so that you don't get any errors in the data. They also plot areas where there's possible terrain obstruction. What they do, they look at the ceiling, and if the ceiling is within 2,000 feet of the ground, if the ceiling's less than 2,000 feet above the ground, then they will assume that there is a terrain obstruction problem. So on the map, what they do is they plot areas where the ceiling is less than 1,000 feet in pale yellow, and where there is possible terrain obstruction, then you will see orange conditions, and that's where the ceiling is less than 200 feet. This is what it looks like on a regional plot. The other one was a CONUS plot. Pretty similar in the colors. The only difference is you're not able to zoom in, and they only give you select stations. Visibility, the way they analyze visibility is simply, they once again plot a grid. They have a grid across the United States, and using METAR data, they try and estimate the visibility at those grid points based upon the nearest METARs. And they analyze areas where visibility is either being reported or estimated to be less than 3 statute miles, estimates based upon that weighting scheme. This is what it looks like in regional view, and you can see that they use the same convention where they use pale yellow to indicate regions where the visibility is less than 3 miles. And then flight category is simply determined by using the ceiling and visibility that we described before, and then using certain criteria. Once again, they're plotting this on a 5-kilometer resolution grid. And then areas that are IFR have either ceilings less than 1,000 feet or visibilities less than 3 miles. And then low IFR is also plotted. That's plotted in orange, and it indicates that ceilings are less than 2,000 feet and there may be terrain obstructions. This is what it looks like in regional view, and it looks very similar to the CONUS. So, the good, bad, and ugly of the CVA. The nice things are, of course, is that it gives you right away areas where there's low ceilings and low visibility. It tells you where there's IFR conditions and possibly terrain obstructions or obscurations where you're close to where the ceiling is very low. And then, of course, this product is updated every 5 minutes using special observations, METARs, and also ghost data. Problems is this is not a forecast. So if you want to see what's going to happen in the future, you have to break out your TAFs and also AirMets. And then also remember that this is an estimate in between reporting stations. So the ceiling and visibility in between reporting stations, in between METARs, may be an error. And of course, if you have great distances between stations, then there could be large variations in ceiling and or visibility in between those reporting stations. And then, of course, if there is very localized variations in ceiling and visibility, that may not show up because of the reporting, the limited reporting of METARs and species in some locations, and also you know, a lot of times you have really small-scale weather phenomena that may be affecting a very small area, and that won't show up either unless that weather impinges upon ASOS or AWOS machine. So to summarize, you need to use TAFs, AirMets, and also mouse over with METARs, get the METAR data to find out what's going on. But this product should help you identify and avoid IFR conditions, especially if you're en route before you blast off. You can use this product. And also it helps you escape inadvertent IFR encounters. So in summary, always use good judgment when you're using the CVA. Also, remember that the CVA is using the most recent weather information every 5 minutes. And also it estimates the ceiling and visibility and flight categories in between stations, and that may not always be accurate. And then the farther away you are from a METAR station, if there's no METAR stations in between, the bigger the error will be, and also the greater the time between observations. Perhaps greater error will be introduced if weather conditions are changing rapidly. So this is what the CAV looks like if you go out and use the CONUS projection at the Aviation Weather Center. You can also use regional. CONUS seems to be really nice because it's very interactive. That is the CVA, and we're done with this video.